The tools needed for test equipment on the 11231 series Chrysler alternator are a 75 to 125 amp battery load tester, also a resistor block comprised of 4 ballast type resistors, 50 ohms each, with an alligator clip on each end. This is a desirable amount of amperage flow because it allows the technician to diagnose a common failure with the Mitsubishi externally regulated alternator. That is partial brush failure at low RPMs and low field current duty cycles. Scanners and full field bypass tests cause 7 amp field currents, which are strong enough to jump the gap and delusion the technician into passing the alternator. Lower field currents caused by the resistors simulate operating conditions, which will detect resistance from a failing or fouled brush when observing the amperage output of the alternator. This is a test block of 4 ballast type resistors available at Radio Shack. They're twisted together at both ends and alligator clips have been applied. They're 50 ohm. Clip the positive lead of the battery test meter to the positive output post on the alternator. Clip the negative lead of the battery load meter to a good ground on the body of the alternator. Apply the load switch on the battery load test meter. Readings between 8 and 9 would be considered normal. Anything below 8 volts, the car should be inspected for a defective bus fuse or fuse link. Looking down at the plug, which has had the harness removed, we're interested in this pin, the one that's closest to the outside diameter and the one that's beside the clip. Install the alligator clip to the resistor block to this pin. The other side of the alligator clip goes to battery positive. Clip the inductive amp probe over the wire as close to the alternator as possible and zero it in. This alternator passes the test. The amperage is steady and even at all times. Be careful not to get burnt when you remove the resistors from the test period. They will be hot. The tools we'll be using to test the Ford G alternator by Ford are an ordinary 125 to 75 amp inexpensive battery load tester and a plain test light. Place the red lead of the battery load tester on the alternator battery output post. Place the black lead of the battery load tester on the frame of the alternator for a good ground. Apply the load switch. Readings over 9 volt would be considered good. Readings under 8 volt would be considered a defective or partially defective fusible link or a bus fuse. Use a pocket screwdriver to unplug the voltage regulator. We need to check the pin voltages at the plug. Looking down on the plug with the flat side of the plug on the left. The bottom, which is normally yellow, or a larger size wire like a 12 instead of a 14 or a 16, this is where the voltage regulator senses voltage. It's going to be battery voltage all the time. We ignore the middle and the other one on the top. Battery voltage is irrelevant, but there should be some voltage on and off with the key. With the flat side of the plug on the left, if the harness passes these tests, the top one is on and off with the key, the bottom one is battery voltage, and a no charge situation still is present, then the alternator should be considered defective. We're not testing the alternator for amperage output during this test. What we want to see is a steady amperage output when a constant RPM is applied. Observe the amperage at an idle. Any minor drop-offs or fluctuations should be considered a defective or fouled brush. Then observe the amperage at 2000 RPMs. Any bouncing of amperage flow should be considered problematic.